Good afternoon, good Sunday afternoon. Well, we're going to check out a couple of items that I got at the Jewett City Flea Market this morning. If you remember that battery charger that I got for $15 and the guy originally wanted 20, he guaranteed it. Well, I get an output on high and I get nothing on the trickle 2 amp trickle charger. 0 voltage, so it does not work fully. Sometimes, you got to negotiate it with these people, because when they tell you something works, most of the time it doesn't, or it doesn't work completely. So it does work on the high amperage, but it does not work on the low current. So it could be something inside, it could be a connection, it could be a circuit problem, whatever. And we're also going to check out that rotary phone and try to get the dial working on it. So let's go in the shop. I got the air conditioner running. And we'll go in there and let's get started.
The 49-year-old Como building looks as good as...
All right, we got the phone on the workbench here. Let's turn this radio off here. All right. Many years ago, when I was young and in my prime, I'd chase all the ladies all the time. Oh, no, never mind about that. Anyways, I used to have a phone like this in my attic workshop. Now, this is back in the 60s. I used to have one of these phones similar to this. Yeah, it's kind of beat up, but it's an oldie. So, we're going to set you up on a tripod here. This camera is a Play Touch, Kodak Play Touch, which is set for HD also. And we don't really need to get into super macro stuff, so we're not using the Sony HDR SR12. We're using the Play Touch here because it'll be good enough. We got to fix this dial here. Well, now it seems to be working good. Nope, no, it spoke too soon. That's quite common on these things. I've worked on these before. And let's see, I don't even know what brand it is, but it's the oldie. You hook it on a nail or a screw or something in the wall, and your wires would come out here. But we're not hooking it up as far as a telephone. It's going to be used as a prop in at least one of my skits. And it's well used. You can see all the scuffs in here and everything. So let's get you on a tripod here, and we'll open this up. A flat blade will do it. I'm going to make sure we're all in camera here. Alright, we got a screw up on the top here, where the hook is, and we got a screw down here. Okay. There's your bell and the clapper. I'll tell you, I need a bigger workbench here. It's all mechanical. Now, I have no idea if you can see that. Let me stop the video a minute and try to hold it steady here. You see the little... Alright. Seems to be binding here. I can feel a bind right in this area here. And this is your contacts over here for when you hang it up. You can see, let me get you on macro here. I'm not too worried about cleaning contacts. We're not using it as a phone. I just want to get this dial to work. So I think probably CRC cleaner will just spray in there to kind of like a degreaser. I used to know a guy that worked at the telephone company. We used to sit in the restaurant and have coffee. And he educated me on how these things work years ago. And there was a wire for the ringer. Normally on a telephone line, as I recall, the red and the green wire were the two wires that you use on telephone. They only required the two wires. And the other two were usually used for another line. That's the way I've always understood that. And we'll get you a little closer here, examination. And the ringer voltage was usually about 48 volts. Enough to give you a little zingle. As I recall, it was 48 volts to set the bell off. And it's a pulsating voltage. So let's get you back on a tripod here. Now, it's a little loose in here. It's not what's causing it though. Now what I'll do is I'll take a small screwdriver and gently tighten up the any screws in here that are holding it in. And I think you can still see me. There's one right here. But this whole thing turns. There's a screw in the middle, which is loose. That's a lot better. It still hangs up though. So we always make sure that no screws are missing. I think we'll just hit some CRC in there. Well, I'm hitting operator. Operator! That CRC spraying in here helped out a lot. So, let's take a look at the dial here. Oh, I spoke too soon. This is very common in these things. They hang up. I don't know why. Spring is good and tight, but you have to give it a little nudge to get it back. So seems to be something hitting. I'm not going to be using it as a phone anyways. going to be primarily a prop. There's two wires that are already hooked up here. Right here, where my thumb is, that somebody snipped off. So let me shut this camera off here and see if I can get in here. I got to get my head right in here. I'm going to try to hold this steady. If you look right in here, how these phones work is, it's a pulse dialer, not a tone dialer like we have now with touch tone. This predates that. And as the dial goes around, and I'm just reaching blindly on the dial in the back, you look at that little lever down at the bottom. Just to the right and lower left at about the 7 o'clock position. See that? Right here. You see how that... So every time you dial, like when you dial 1, it hits, it makes the contact and lets it go 1 time. When you dial 2, it does it twice. 3, 4, and so forth. You can see it go in and out very rapidly. Okay? So essentially, you can do almost the same thing here. There was a knack. You could, years ago, they used to hit the receiver and get the attention of the operator. Because these contacts here would make and break the same as these. This will hang up your call or open the line when you pick the receiver up off the hook. But it also, if you jiggle the handle here, and if you were able to do it rapidly enough, you could actually make a phone call with it. Be a hit and miss, though. You wouldn't always hit the right number. So I sprayed the CRC cleaner in here and in here. It seems to be doing better, but it's still got a binding action here. See, it sits right there. It sits. If you dial like 1, it doesn't want to, it seems to bind it there. If you go 2, it'll sit there. Go 3, it'll sit there. 4, it'll sit there. So it's still, you have to give it a push back. I don't know why. I thought I had fixed it, but I think this needs some oil in here. But I'm not going to do that now. I think a little light oil in here. You can see there's a wheel that spins around in there. And that could be binding, but I'm not sure. Not 100% sure about that. So I did want to just show you this. Primarily it's going to be used as a prop. Well, I thought I had it fixed, but obviously not. It seems to be when I sprayed it with the CRC, which I'll do again here, it seems to work until it dries up. Could be wrong, but let's see. Yeah. You know what that tells me? I need oil in that little thing. See that? It works good until CRC dries up. So we need to get a little oil in here. We're not going to do that now. I want to get onto the battery charger. So I'm going to clean this thing up off camera, inside and out, as much as I can. And try to fix this cord here, which comes out here. And I think, yeah, there's a grommet. See this here? That's a strain relief. I think it probably goes on in the screw. Where this screw comes down through there, it's captive in here. I think the strain relief goes in here. It holds the wire down, so it just got to be put back in there to prevent this from getting pulled out. This is very old and we don't want anything to happen to it. Okay, let's get on to the battery charger before we run this video into another hour-long boring video. Okay, when I put my ear up to this, I'm going to move this meter over here. I think you can still see it. When this switches down to the bottom, it's low. 2 amp, low 2 amp, high charge and boost. Okay, nothing on the meter. All right, so right now we're on the low, and I got the battery clips clipped to the plastic handle here, so they won't short out. It's reading 0.688 volts. In other words, a little over half a volt coming out. The center is off. I can hear the humming. This is high. 12.45 volts. Okay? And very quickly sparking these together in the other shed, it does work. So I should be getting, let me put my meter leads right in here, and they probably won't stay. Let's just see if I can get them to stay. Nope. No, you got to use clip leads. I never have any luck holding anything on. I should know that by now. Yeah, good old clip leads. Okay, this one makes contact, the other one didn't. 12.4 volts right now. Now we switch it down to the low. Nothing, just 0.556. In other words, a half a volt. So that's all we're getting on this here. I flip this. The middle, there's going to be nothing. And there goes my leads again. Alright, 12.45 volts. So there's no output on the low. So I don't feel too bad knocking this guy down to $15. He says it works. Well, he didn't lie to me totally. It just don't work on the low range. It's 2 amp trickle, 12 amp charge, 50 amp boost. So it only works on the high. Alright, it's pretty clean in here. This is your high and low switch. So when you push this button down here, you're throwing these two top contacts on, the two white wires, and when you flip it up, you're throwing it from this to this. So let's put an ohm meter on that and verify if this switch is working or not. It's pretty straightforward. You got your output rectifiers here, your circuit breaker to disconnect in case the load gets too heavy on it or short out. And that's basically it. Alright, well, the switch pushed down, we got 0.2 of an ohm. The switch in the middle is off, there's no connection. And the switch up is not showing anything because we got to bring our lead down to here. We got 2.2 ohms here. Got a little resistance on those contacts in the switch. Now it's 12. Could be a problem with the switch. And now we got better contacts. Alright, so the switch is up. I got black leads here connected to my ohm meter here. Alright, sorry about the handheld thing, but I just can't get coordinated with these cameras, so I hope you can see that, alright? Now it looks like the neutral, there's the neutral, the white, goes into the line cord here, goes into the transformer. The brown goes to the bottom position, so when you got this up on high, as I said, if you look at the switch here, it's up, which is the high, the boost output, that's the part that works. And the switch is up. This and this are shorted out by way of the switch. You put the switch down, you're going to have this one and this one shorted out. And this one open. So I guess it does change the tap on the transformer. And this is the hot, the hot side, which connects directly to the line cord. So it would seem to indicate that this switch is a problem, because I can't think of anything else. I don't think it's a transformer. If it is, well, I guess I did all right for $15, but I can't use it for a trickle charge, but I've got a small battery charger for that anyways. I just needed something that would charge at a faster rate, and this would do it if I just leave it in high. Well, I got the voltmeter on the clip leads, and I got it's only 0.9 of a volt, and I got the switch down, which is shorting out the two top contacts. I'm getting, the switch is getting continuity, so there must be an open on that part of the primary. I'm not quite sure how that works. That's the 2 amp, and how it gets to 50 amps by just changing the primary tap don't make sense to me, but so this only works on the high. I don't want to flip this now because I got the two things shorted out. So I would say that one of these is open. Alright, I just snipped that cable tie. Like I suspected, here's your hot wire, goes directly into the transformer. Obviously that part of the winding is good. Here is your neutral, and it goes to the center of the switch, which would seem logical. And then this wire goes to the top one, and that's the section where when you push the switch down, you shorten these two out. So my indication my feeling is I should say that this portion of the winding, this here, is open. So when I put an ohm meter across the two white ones, I got an open reading. And naturally I would, because that's the neutral of the plug, and it's not plugged into the wall, so it'll be open circuit. So what I was going to do now is to see if I got a reading with the ohm reading between the brown and the white, which, as you can see, this white on the top terminal of this switch goes to the white wire winding on the transformer. The other white goes to the neutral, so the brown goes down here. So in a sense, when this switch is down here, this brown don't come into play at all. Okay? Because you see the switch is down. When the switch is down, your insides of the switch are making contact with the middle and the top. When the switch is up, the internals of the switch is throwing the middle to the bottom. Okay? When the switch is up and it's throwing the middle to the bottom, that's the high end, that's the high amperage. That part works. So we know we've got a good winding here, from here to here. We're taking the neutral and connecting the neutral to the brown, in a sense, by way of this switch. When this switch is down, we're connecting the neutral to this outside winding here, which could be a high resistance winding, but then if it is, it should put out a higher voltage. I think this winding is open. Right here. I think that winding tap is open. We can verify that by taking a resistance reading from here to here and from the hot to here by way of the power plug. So if we get a reading from here to here and we get a reading from here to here, then it's not. So then it would be a big mystery as to why that's not working. So I don't think this switch is wired wrong. It's open. I got my ohm meter clipped to the white, which is this winding. Yeah. And the bottom terminal, which is the brown. So we got the ohm meter going from here to here. Nothing. Open. And we are on ohms. Okay, from the brown, which is the center tap, I guess, of the transformer, to the black, which is the hot, and this plug, as you're looking at it, as you're looking at the plug, the hot is on the right, neutral is on the left. We're getting 1.5 ohms. From the hot pin, which is the black, to that white wire, which is the outer tap of the transformer, we're getting nothing. All right, there you have it. Oh, I don't feel so bad getting this for $15. I know people have criticized me for trying to beat down somebody on the price. I'm very skeptical of buying anything that looks like it's in mint condition for dirt cheap, because there is always a problem 9 out of 10 times. That wasn't the case with this B&K power supply for 10 bucks that I bought last year on the top of the shelf. I was lucky there. Okay, but when it's not all lost, we just don't have the feature of a trickle charge, but you don't really need it anyways, because I bought it for the high amperage. Alright, this is the end of the video. Thanks for watching.